So for this chapter, we're going to be talking about the Milky Way galaxy, which is our galaxy. We happen to live off to the side of the Milky Way galaxy. Our Milky Way galaxy is absolutely huge. It's huge compared to us. It says here 200 billion stars. That current estimate's actually been bumped up. Some people say 300 billion stars. And since we're trapped inside the Milky Way, we can never actually get a picture of it from outside. So if you ever see a picture that looks like a real picture of a galaxy and it's labeled Milky Way galaxy, it's not right. It's not true. It's a galaxy that looks like what we think ours looks like. But all we can really see is the Milky Way wrapping around us. We can never actually be outside of it to take a picture. We're trapped inside of it. It would take us 100,000 years to get to the next nearest star with our spacecraft that we have today. And all of the stars that you can see with the naked eye are pretty close by in our neighborhood. So our Milky Way has three components: the disk, the halo, and the bulge. And we're going to go through them one by one. So let's do the disk first. Right. From above the disk, it would look round, but from the side of the disk, edge on, it would look flat. So here's the edge on of the disk. We are in the disk, but off to the side. We are nowhere near the center. For scale, the Milky Way is about 100,000 light years across. That means even if there were aliens on opposite sides of the galaxy, one message would take 100,000 years to get to the other side of the galaxy. Compared to its width, 100,000 light years, it's very thin, 1,000 light years. And in the disk, you're going to find nebula, clouds of gas. You're going to get forming stars. You're going to get open clusters, bits of dust. You're going to have stars that are dying and turning into white dwarfs, black holes, and neutron stars. So all of that can be in the disk. The spiral arms are going to be in the disk. Okay. If we look at the Milky Way galaxy's disk, the stars go around the galactic center, and that might take about 230 million years for one orbit. But if we watch the orbit of one star going around the galaxy's disk, you can see that its primary motion is orbiting around the center. But while it's doing that, it's also bobbing up and down a little bit. The bobbing up and down happens because when a star was formed in an open cluster, it would have gotten a little bit of random motion, up. But once that star gets too high above the disk, all of the matter is underneath it. And so it feels a gravitational pull back down. And it'll be pulled back down through the disk. And then it carries through the disk with its inertia, with its momentum. And now it's under the disk and all of the mass is above it. And that's going to pull it back up again. So it's just kind of overshooting the gravity of the disk and it gets pulled back. And that makes it bob. Right, the primary thing out in the halo is dark matter, but we're not going to worry about that until a couple more chapters. The visible thing that is out in the halo are going to be globular clusters. Old clusters of stars with no nebula, no recent star formation, and they date to about 12 or 13 billion years old. And so we actually think that these star clusters formed as the Milky Way was still collapsing. We think these formed before the disk even happened. And since these formed before the disk even happened, they do not have organized orbits. They don't all go in the same direction like the disk does. They pretty much have random orbits. The bulge of the galaxy has the highest density of stars. So if we look in the infrared, we can actually see the center of the galaxy pretty well. We can see through a lot of gas and dust. And that's where there's a huge amount of stars. Also in the bulge, right in the very center, we do have a supermassive black hole. If you guys remember Sagittarius A star, that's our supermassive black hole with 3.6 million times the mass of our sun. And another thing about the bulge is that it doesn't really have any nebula, so you're not going to have any young stars. So these are going to be pretty dated. The bulge stars do not have organized orbits like the disk. So we're trapped inside of our galaxy. So we can never get a picture from outside, but we can look at the galaxy in all the different colors of light. So here's what our galaxy looks like in radio. Most of the radio light comes from the disk. The galactic center in all of these pictures is right in the middle of the map. And then imagine this map wrapping around you, so it's a full sky map. Here's a map of our galaxy in the infrared. So a lot of the nebulas and gas and dust will glow in the infrared in the disk. These big black streaks are actually just missing data. They're not real. Visible light. Visible light, we see the Milky Way. Lots of light from stars, but also lots of black bands where there are dark nebula that we cannot see through. The X-rays seem to actually come mostly from kind of up above and down below the disk. So we actually think a lot of supernova explode out their hot gas, and that hot gas can escape the gravity of the disk for a while, so you end up with a lot of hot gas above and below the disk. And if you were to look at our galaxy in the gamma rays, our disk lights up, and it takes a while to understand why should our disk, which is full of pretty cold gas and regular stars, be giving off so much gamma ray light, which really usually only comes from supernova, which should look like a bright point source, not the whole disk. Outside of our galaxy, there are a lot of extreme events like supernova, and they send particles through space that are really fast, really high energy. And when those particles from other galaxies come and slam into our gas and our dust, it gives the gas and dust enough energy to quick give off a little bit of gamma ray light and cool off. So this light is actually our galaxy getting hit with, we call them cosmic rays, high energy particles from other galaxies and from some of our own galactic events as well. So with all of these different views, we can try to piece together what's happening, try to piece together the map of our own galaxy. So here is a picture, which is art, of what we think our galaxy looks like. Our galaxy is a spiral galaxy, so in our disk we have these spiral arms, basically extra bunched up regions of gas and dust. And our bulge is not perfectly spherical. We actually have what we call a bar. A lot of stars have interesting orbits, we call them box orbits, that make a bright bar of stars across here. So we have a barred spiral galaxy. Here's a map. There's our central bar for our barred galaxy. And there's the center, your supermassive black hole. And you've got the Norma arm, a ring, the Perseus arm, the outer arm, the local arm, hint hint, that's where we are, the Sagittarius arm, and the Scutum Crux arm. So that's a cartoon version of our galaxy. All of the stars fit inside of this disk edge, but there is more hydrogen gas that spreads further out, so that's this larger boundary out here, the disk edge for the hydrogen gas.